So today we are discussing the basic concepts of mass. So in the basic concept, first we are discussing the coordinate axis. Now we are discussing coordinate axis. So coordinate axis is nothing but, right? So this is denoted by x and this is denoted by y. So these two lines are mutually perpendicular, and they are intersecting at here. So this intersecting point is denoted by O. It is called a origin. And here it is denoted by y, and it is the y dash, and it is the x dash. Okay? Right. Here x dash O x. This x dash O x is called a x-axis, and y O y dash, this line is called a y-axis. Okay, x-axis and y-axis. So if you take a point in xy plane, so take a point x comma y. It is a point. Okay, so here. Right. So this is the point P of x comma point in a xy plane. Here this x is called a x coordinate and this y is called a y coordinate. Okay. So this point here, so this point is in xy plane. Okay. Right. So take the notes. The coordinate axis divided the plane into 4 equal parts. Means, so this is the coordinate axis that divided the plane, is all the plane in 4 equal parts. So this is the part 1, this is the part 2, this is the part 3, and this is the part 4. So the coordinate axis is divided the plane. This is the total plane. So that plane is divided into the 4 parts. So each part is called a quadrant. Next we are discussing the distance formula and collinear, non-collinear, and triangles. Now the distance formula. So the distance formula here. So what are they here? Let a of x1 comma y1 and b of x2 comma y2 are 2 points. I am taking, these are the 2 points. Here I am taking points A and B. So a of x1 y1 and b of x2 comma y2. These are the 2 points. So what I want to find? I want to find the distance between these 2 points. The distance means the length between these 2 points. The distance between these 2 points. How to calculate? Very simple. By using this formula, we are calculating distance between these 2 points. Okay. Right. So how to AB is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay. So this is the formula for distance. Suppose we squaring on both sides. Squaring on both sides. So what you get here? AB square is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is also whole square. And here square and root get cancelled. So what you get here? AB square is equal to x2 minus x1 whole square plus y2 minus y1 whole square. So this is the simplification. Okay, so this is the distance formula. Next, collinear points. Collinear points means, so if you take all the points, 3 or more points, they are lies on the same line or not. We have to check they are lies on the same line or not. If they are lies on the same line, we can say it is a collinear point. If they are not lies on the same line, they are called a non-collinear points. Observe here. Suppose, so these all are the points. Okay, these all are the points. So 3 or more points are lies on the same line. So now I'm drawing the one line here. This is the line. So how many points are here? This one, and here also another one. Here. Okay, observe here. So how many points are lies on the same line here? This is the one line. 1, 2, 3, 4. So these points are lies on the same line. So these 4 points are collinear point. Now observe here remaining points. here these are the remaining points. So these points are does not lies on the same line, does not lies on the same line. So these are called the non-collinear points. These are called the non-collinear points. Okay, are you understood? Next, triangle. So triangle, how to form a triangle? Very simple. So if 3 points are non-collinear, then they can form a triangle. So non-collinear means, already I told you, non-collinear means they are not lies on the same line. So suppose I am taking here 3 points. This is the 1 point, this is another point, this is the another point. So these are the 3 points. These 3 points are non-collinear. Okay, so these they can form a triangle. They can form a triangle. Okay, right. So this triangle containing 3 vertices. So A, B, C. These are the 3 vertices. And next 3 angles. So here angle, it is containing 3 angles. Okay, right. So the triangles are divided into the 5 parts. So the first one, okay, equilateral triangle. Equilateral triangle means all sides are equal. All sides are equal. Suppose this is the triangle. So these all sides are equal. All sides are equal. This is called a equilateral triangle. Next, isosceles triangle means any 2 sides are equal. If any two sides are equal, so that is called a isosceles triangle. So suppose these two sides are equal. So this is the different. Okay. Next, right angle triangle. Right angle triangle means in a triangle, one angle measure should be right angle. Right angle means 90 degrees. So one angle is 90. So A, B, C. Okay. Here observe here. This is the right angle. So this is called a right angle triangle. Next, obtuse angle triangle. Obtuse angle triangle means, so one angle measure should be one angle above 90. Above 90. So the diagram will be in the form of, this is the 90 now. So this is the 90. Above 90 means like that. So like that. So here this is the angle. So A, B, C. Here this is the above it. This theta is, so thus theta is above 90 degrees. Here acute angles. So acute angle triangle means all the angles are measured should be less than 90. Less than 90. So here, so all angles are less than 90 degrees. All angles are less than 90 degrees. So that is the diagram here. So this is this. So these angles are less than 90. It is called a acute angle triangle. Okay, are you clear? So I am dividing into the 5 parts. So these are the triangle, the concept of triangle. Next, the area of a triangle. How to find the area of a triangle? Suppose here, so this is the triangle. It is containing 3 vertices, A of x1, y1, here B of x2, y2, and C of x3, y3. So by using these 3 vertices, we have to easily calculate area of a triangle. So very simple. So very simple area of a triangle by using these 3 vertices. So here the formula is the area of triangle. Area of triangle is equal to. So the formula is half of. So what are the points here? x1, y1, x2, y2, and x3, y3. So first where are the x coordinates? So what is the first here? x1. The second one is x2. The third one is x3. And so which point we have started and end with that? So x1. Next here y coordinates y1, y2, y3, and y1. So close mod. Okay. Right. So here simple cross multiplication. We have to do cross multiplication and add them. So the cross multiplication means here x1 into y2 minus x2 into y1. So minus. So x1 into y2 minus x2 into y1. So next I have to add it. I have to add to next term. So here also x2 y3, next x3 into y2. Okay, next say add it. Next here cross multiplication and add, cross multiplication and add, and cross multiplication and add. So we are getting the simplified, we are getting an area of a triangle. Or so if you simplify this concept, we are getting one final formula. So that is also half of, so final formula that is also half of, right. So first we are done x1 plus x2 plus x3, bracket close, sum are close, open the bracket here. So observe here, so I am drawing the one concept here. So y1, y2 and y3. So here is the cycle. So y1, after y1 we are getting y2, next after y2 we are getting y3, next after y1 y3 we are getting y1. So this is go to the clockwise direction. So right. So first x1 is completed now. So 1 2 3 actually, so sorry, I have to take 1 2 3. Okay, take 1 2 3. Okay, 1 2 3 simple. So that is was here. So which is the complete here? 1. After 1 we are getting here 2. 2 means we have to take here y coordinates. We have to take here y coordinates. Y2 minus y3. 1 2 3. Clear? Next. So here x2 2. After 2 we are getting 3. So I have to take inside only y coordinate. We have to take inside y coordinates only 2. After 2 we are getting 3. After 3 we are getting here y 1. Okay, after 3 we are getting 1, that is the y3 minus y1. Next after here 3. After 3 x3, so inside the bracket after 3 we are getting a 1. So that is y1 minus after 1 we are getting 2, that is y2. Okay, so simple trick. We can easily calculate area of a triangle by using this formula. So here these both are same formulas. So what I mean here, cross multiplication add, cross multiplication add. Okay, we are doing same. If you simplify this concept, we are getting the final formula. So we can use any one. You can use either this one or this one. You can use any one. Okay, right.